the census, which is, I think, the best picture and portrait of society that we have had and we have, only changes every 10 years. And a lot of the processes and changes that we're interested in to look at in cities unfold in a much faster cadence, right? So within 10 years, there's a lot of things that go on within cities, and we want to be able to capture that. So that's where satellite imagery comes in.
Welcome to another episode of the Mapscaping podcast. My name is Daniel, and this is a podcast for the geospatial community. Today I'm talking with Dani Arribas Bell. So Dani is not just another victim of my terrible pronunciation. He's also the Senior Lecturer of Geographic Science at the University of Liverpool. And today on the podcast we're going to be talking about something called the Urban Grammar Project. And this is a project which seeks to make a connection between form, function, culture and satellite imagery. But I'll let Dani tell you more about that in just a second. I'll be back at the end of this episode to ask you for your help and to point you towards a few resources that I think you might find interesting. Just before we get started today, I want to say a big thank you to our sponsor, Regrid. So Regrid are the parcel data people for the US. So think of parcel data as being the legal boundaries of properties. And America is made up of these legal boundaries, and they have owners, they have assessments, they have current land use. And these boundaries surround everything: homes, parks, commercial buildings, farms, wild places, everything. But wait, there's more. It's not just parcel data. You can also get parcel data with matched secondary addresses. So what this means is that each parcel, it comes pre-joined with all known addresses in the United States. But wait, there's even more. You can get parcel data with matched building footprints. And what this means is that you get a geometry of the building footprint that lands in the right place in the parcel data, and these two things are matched. So growing up in New Zealand, every time somebody in the media said, wait, there's even more, it usually meant that there was a free set of steak knives involved with it. Unfortunately, this is not the case with Regrid. It's just parcel data with matched addresses and matched building footprints. But if you're also interested in steak knives, maybe you should talk to them. Maybe Regrid can help you with that too. Hi Dani, welcome to the podcast. So today we're talking about something called urban grammar. Yeah, I think I'm going to leave it there, but would you mind just introducing yourself to the audience, please? Perhaps letting us know what your background in geospatial is, where you work now, and then we'll move on to the Urban Grammar Project from there.
Okay, thanks very much for having me at the podcast. My name is Dani Arribas Bell, and I'm a Senior Lecturer in Geographic Data Science at the University of Liverpool. And I also spend quite a bit of time at the Urban Analytics program at the Alan Turing Institute in London.
That is a lot of great sounding titles. How did you get involved in geospatial? I'm assuming all of this has something to do with geospatial. So how did you get involved in this kind of research?
Yeah, so I was actually originally trained as an economist. All my studies, including my PhD, is in economics. But while I was doing my PhD, I started getting interested in cities, and that was my way into geospatial. I think through research on cities, I started getting more and more interested in the spatial aspect and the spatial dimension of urban environments, and one thing led to the other, I suppose, and I ended up getting quite involved in software development for geospatial and use of geospatial data in various contexts.
So just out of curiosity, when you were more interested in economics, were you also doing software development in that area?
No, I started in economics, and then somehow I started getting interested in cities and the kinds of things I wanted to do at the time. There wasn't really a software that would do it for me. So I started getting interested in that, and I realized that I really liked that. And I also really liked the geospatial aspect of the research. So I started slowly but surely moving more and more away from economics and closer to geography in academia and more generally geospatial.
Just before we get into your interest in cities and tie it into this project called the Urban Grammar Project, I'm curious about how you got into software development in geospatial. Like, was it just a natural process? Did you realize at a point that, hey, I won't be able to explore research the things I'm actually interested in if I don't do this? Because it seems like a big jump.
Yeah. Well, I think it came pretty natural. Maybe from the outside it doesn't seem as obvious, but I think in science in general, writing software is not, or at least in certain domains of science, and economics is probably one of them. And the part of geography that I got interested is also another one, that through GIS and similar areas, writing software is something that's not completely foreign, at least as a user. What probably was a little bit different in my case was that I started getting more and more interested in those areas, and at some point I found myself writing new software or writing new tools. And I was fortunate to find a group and a community of people who fostered that interest and supported me. And that was pretty crucial in my somewhat transition into from code user to code writer.
So you're pretty heavily involved in academia now. Do you see this as almost being a prerequisite when you think about research today that you need to move from code user to code writer?
In some areas, yes. I think if you're going to be at the frontier and if you're going to be pushing the envelope of of what's unknown and what's known, I think a lot of that happens today, or the lingua franca in which we communicate many of these ideas is more computer code than it could have been math a few years ago, or narrative. And this is not to say that those are not relevant; they're very much so. But I think code is a new one, is a new sort of medium to communicate ideas and to discuss concepts and to advance knowledge. And I think if you're interested in getting into research, at least for certain domains or disciplines, writing code is something that you probably need to get comfortable with, and writing code that does things that no other code, so to speak, does is something that at some point you will probably end up doing.
Do you think we can have reproducible research without, without writing code, without showing our work and having perhaps using Jupyter notebooks, for example, and sort of saying, well, here's the data and here's the code, here's the functions, the process I ran through the data to get these results. Any of that going to be possible without being able to code?
A great question. I suppose in theory, yes. I think reproducibility is really about being transparent in the steps that you take. And in fact, some of the early examples of reproducibility, like the early observations of Galileo of the sky, do not involve code. But in practice, and at least in my experience, having code is a very direct way of documenting what you do. In some ways, the code is almost like the documentation itself. So if someone knows how to read code, they should be able to follow. So I would say in theory, you don't have to write code for being reproducible. In practice, I think it actually makes it a lot more direct and easy to be reproducible.
Well, thank you very much for providing a little bit more context for us, how you got into the space and how that interest developed over time. I really appreciate that. So we started off, you were studying economics, got interested in cities, and moved over to the geospatial aspect of studying urban environments. And now you're working on a project called Urban Grammar. Could you tell us about this project? What is Urban Grammar?
Urban Grammar is a project at the Alan Turing Institute that I'm working with my colleague Martin Fleischmann. And the sort of one line pitch of the project is trying to use satellite imagery and artificial intelligence and machine learning to better understand the spatial dimension of cities, to understand how the different building blocks of cities, as we think of them, are distributed and arranged over space, and how this distribution changes.
So this sounds like a slightly different approach, but why couldn't you just go to OpenStreetMap, download all the building data and start doing analytics on that to find out what the spatial distribution of different kinds of buildings looks like? Why would you need to involve satellite data?
So the short answer is you could, and in fact that's the first step that we take in this project. So the idea of the project is developing first a classification of patterns that you may find in cities of the distribution of these building blocks of what we call urban form and urban function. And for developing this classification, what we want is to get as much detail and as much granularity as it's possible. And for that, we actually do use a lot of data sources like OpenStreetMap, like official data sets in the UK from the Ordnance Survey, from the census, etc. These sources are amazing, and I'm a firm believer that particularly official sources and in some cases data sets like OpenStreetMap are probably our best shot at the moment at getting a good and granular picture of what cities look like. The issue with these data sets is that they don't necessarily change very frequently. And in the extreme data sets like the census, which is, I think, the best picture and portrait of society that we have had and we have, only changes every 10 years. And a lot of the processes and changes that we're interested in to look at in cities unfold in a much faster cadence, right? So within 10 years, there's a lot of things that go on within cities, and we want to be able to capture that. So that's where satellite imagery comes in, and where remote sensing more in general comes in. It's the source of data that's granular, that is already good and is getting even better, and it's probably going to get a lot better in the near future. And it provides us sort of a boost to to sort of combine with traditional sources to get the best picture, and then to sort of roll back and forward that picture over time, which is the bit that traditional sources or vector sources couldn't necessarily give us.
So how do you make this connection? Is it simply a matter of saying, okay, I can see a house in this data set, in our OpenStreetMap data set, and some of these other data sets we've got from these official sources, and then matching it to the house that you can see in the satellite image, or is there something else going on here? I'm looking for that connection that at some stage you're going to need to make between the data sets you have now, the analysis you're doing on them, and the satellite imagery you hope to use in the future.
Yeah, so the main bridge that we use to connect these two worlds, if you wish, is what we call it's our classification that we've developed that we call spatial signatures. So the spatial signatures conceptually is the set of types or the set of classes of urban patterns or patterns of the distribution of urban form and function that we can observe and we do observe in cities. We developed this classification using a whole bunch of data sources combined with a little bit of machine learning stardust. And then this gives us a classification, which ultimately is a delineation of boundaries. So what we're doing, I sometimes call it the gigantic cookie cutter that we come up with and we put on top of the geography. In our case, for this project, is for Great Britain. So we come up with this large cookie cutter that divides Great Britain into areas that have the same pattern when it comes to urban form and function. And then once we have these classes that we call signature and these patches that we also call instances of signatures, then we use those as in the machine learning jargon as labels, if you wish, or as examples to train an algorithm that hopefully is able to recognize those patterns entirely from the information encoded in images coming in this case from satellites.
Wow. It sounds amazing. Can we talk a little bit more about these signatures that you've developed? Because when I was looking through some of the documentation for this project, I see things like form-based signatures, spatial signatures, function-based signatures. I don't know anything about these. Could you tell me about them and how are they different from each other?
Yeah, absolutely. So the main classification that we're working with is what we call generally the spatial signatures. And these are classes or types that are developed using both information about the form of the patch and the function. And by form, what we mean is what does that space that we're looking at look like? What is the spatial configuration of the elements of the building blocks that make up the urban environment? So you can think of things like properties of the street networks, properties of the building footprints, and properties that derive from the interaction between building footprints and street networks. And for these, we draw from an emerging field that it came out of the intersection of urban geography, architecture, and planning that's called morphometrics. And it's entirely devoted to coming up with ways of describing quantitatively the morphology of urban environments. So that's one half, if you want. And we've also developed a classification that's entirely based on morphology because in some contexts it's useful. The other half and the other part of the spatial signatures is what we call function based typologies or function based data, sorry, I should say. And these are for developing these part of the signatures, what we use is data sets that tell us something about the kind of activities and the kind of stuff that goes on, if you want, in these areas. So on the one hand, we have morphology, which is you can think of it as the container, and then function is really the content, what goes on within cities. And for these, we use amenities from OpenStreetMap, for example, or we use land use from land use classifications, or we use a little bit of census data for workplace, industries, etc. And to develop this massive cookie cutter I was talking about a minute ago that we call the spatial signatures, what we use is combining both form and function because the two talk to each other and interact in really interesting ways. So we're more interested in the outcomes that come out of the two interacting than of form only or function only. Even though, as I said, we also have classifications that only consider one of the two because in some cases they can be more useful for some applications.
Just out of curiosity, was there ever a time when there wasn't a strong relationship between form and function?
Ooh, that's a great question. I suppose it's a bit of an educated guess that I can give here more than anything, but my sense is that not really, because they are the two sides of the same coin. That's at least how I see it, right? It's the way I was describing form and function a minute ago, almost as the container and the content, you can't disentangle the two. Definitely not in cities or in urban environments. So form somehow constrains function. You can have, high financial services in the middle of the countryside, probably the same way that you can have countryside in the middle of a dense urban environment. But once you have that function in place, function also starts shaping form. One of my favorite examples of that actually happens in the city I live in today, Liverpool, where there's a neighborhood that's called the Rope Walks, and it's made up of narrow but really long and downward sloping streets. And the reason why these streets are long and narrow is because they used to be used for making the ropes that would then go onto the ships in the port. Liverpool was a big port city. To me, it's a fantastic example of how function, the industry that sort of settled in that part of town, shaped the morphology of the city and gave rise to these really long and narrow streets. And there's lots of examples in cities of how once a function establishes itself in a location, starts also shaping the form. So I think it's really hard to disentangle the two and take them independently.
So I had a couple of thoughts here, and one of them was, okay, so we've just been through this crazy time with a pandemic, and a lot of the jobs that we've had have moved outside of the city, so they've been decentralized. They've been happening in people's homes. So homes are becoming workplaces, places of business, places of high finance, perhaps. So one of my thoughts was, I guess it depends on where the snapshot in time was taken of each data set that you're looking at, because a house now has a few more functions that it didn't have before. For example, what do you think of that idea that that you are looking at a snapshot in time? If I have a house, it says it's a house in OpenStreetMap, but I go to some official data set and I say, oh, it's a place of work, or it's a small business that's running in there.
Absolutely. I mean, I think something that's important to keep in mind is that urban form and function, of course, they interact with each other and they're very much related. That doesn't mean that they move in sync at the same time, right? Usually one follows the other, and then once the other one has changed, starts slowly influencing the original one, right? So with the example you're giving, I think it's a fantastic example. I think we're in for, urbanists of all kinds, and particularly those interested in form and function, are, if you want to look at it, are in for a treat with the pandemic, in the sense that I think there's going to be a lot of really interesting changes unfolding over time when it comes to form. The way cities look today are the result of technologies and the result of cultural norms that probably started kicking in 50 years ago, 100 years ago. City centers are dense because at the time, we decided that the most efficient way of working was the office, or at least for certain industries. And that influenced how we build cities and how we move in cities. The idea of commuting is very much linked to having a workplace. And when these starts breaking because of, again, maybe technology, then maybe cities will start adapting to those too, right? And maybe the city centers will be dense, but will be dense places of entertainment. They will be full of amenities, but maybe not as much of work. And the same thing will probably happen with suburbs or with more peripheral areas of cities, that we used to think of them as only the place where you would go to sleep or would you spend the weekend. But when you start working 3 days a week from home, maybe more amenities will start popping up there. And maybe the restaurant that you would used to go for lunch when you were at the office will start moving more and more into residential areas for people who also want a lunch break when they're at work, but they just happen to be home.
You talked about classification, so a group of classes. Firstly, I'd be curious to know what number you settled on. Like, what number was an appropriate number of classes to describe these geographic areas that we're looking for here? And I guess the next part of that question is, why that number? Why not just go hundreds of thousands and get as detailed as possible when we think about classifying these areas?
That's another great question. So I should say also that the way we're proposing the spatial signatures is almost operating at two levels. One is at a conceptual one, in which is this way of looking at form and function that uses data to derive a bit more insight. And at that conceptual level, you could develop spatial signatures arguably on any part of the planet. The project in particular has an empirical aspect, or a more applied part of it, which is focused on Great Britain. And for that, for our application, we developed 16 classes. This is a bit more interesting than it might appear, because the number of classes in itself, we think it's also, it's a result in itself, is not a constraint of the classification that you want to build. When we're building this classification and coming up with the typology, we try a lot of combinations, and we look at a large series of algorithms and combinations of parameters with those algorithms. And the final number that we settled on is a reflection of the result that we think fits better reality, or molds itself better to the data that we're using. So the fact that we're using 16 and not 160 to us is it's a reflection of the degree of complexity, if you want, that form and function has in Great Britain. Prior to the national classification, we did a few experiments in a few cities around the world. We looked at places like Barcelona in Spain, or Singapore in Southeast Asia, or Houston in the US, or Medellin in Colombia. And for each of those cities, we did a separate classification. So for us, it was really interesting to see how what we thought was the statistically appropriate number of classes that you would derive from each of those cities was varying greatly. And it was varying greatly not in ways that you would necessarily expect. So, for example, it wasn't varying in a way that larger cities had more classes while smaller cities had less classes. It was varying much more in how, how rich the urban fabric of the city, or what we interpret it to be as the urban fabric of the city, was. So to give you an example, Houston, which is the archetype of urban sprawl, we only came up with, I think it was 8 classes. While for Barcelona, which is a much smaller, much more reduced city, but a lot older one, with arguably a richer history, in the sense that it just goes back further in time, we came up with many more classes, right? And for us, this was a reflection not of the fact that it was a larger or a smaller city, or that we had more or less data. It was a reflection that the urban fabric had more granularity and more richness in Barcelona, which, if you think about the history of the city, the fact that it's a city that's several thousand years old, that has been large for a long time, and that has had several ways of technology, society, and culture somewhat building it up, it makes sense that you would find richer patterns when it comes to form and function. While Houston it's a fairly large city, but it was mostly developed in the post-World War II period, a period where there was one main technology, which was the automobile, and the general understanding of what cities were or are was similar. And for us, once you think about it from that perspective, it wasn't an entirely surprising result, but it was nevertheless it was quite refreshing to find in the data.
Thank you very much for walking us through that. That was really, really fascinating. You talked about these classes reflecting reality, and I'm curious, how did you ground truth them? I guess it's one thing to create these classes, it's another thing to go and test them against reality and make sure or confirm that they reflect what's actually happening on the ground.
Yeah, that's again another tricky but fantastic question. I guess the short answer for that is that there isn't a way to fully ground proof these things, because the whole point we're doing is we don't know what these classes are, right? If we did, we probably wouldn't be doing it. The first thing I would say is that a lot of this classification is trying to unearth patterns that we maybe have educated guesses, but we don't have a sort of gold standard of what it actually is. If we had it, we probably wouldn't be doing these. Now, having said that, it doesn't mean that we're just, running the algorithm, churning out some data, and then putting it out there. We've done a lot of work, both qualitative and quantitative, to convince ourselves that what we're producing at least makes sense. And we do that as a combination. On the qualitative side, we look at places that we know, well, the places where we live, the places where we've been. When I say we, it's of course Martin and I, but we also try to gather views from other researchers, and we try to sort of ground truth in that sense, asking urban geographers, asking data scientists, asking people who know the cities in particular, does this sound sensible to you? Maybe not to the 10th degree of detail, but broadly speaking, does it sound sensible? That's one way of ground truthing. The second one that we have is we don't have another spatial signature classification, or at least not yet. But there are other classifications that look at form and that look at function, or that look at parts of form and function already. And as much as we can, we compare ours with those, and we look at where they agree, and also probably more where they disagree, and we try to understand why. And in some cases, disagreements are a good thing because it shows the value of our classification, but it could also show that there's something wrong with our own way of doing things. So that's another way we have to ground truth, if you wish.
So if I could just try and summarize just for a second here. So you've looked at a multitude of different data sets, and you've created these signatures based on form and function. And then you've run a model over the entire area of Great Britain, and you've divided it up into 16 classes, I believe you said. So Great Britain is essentially covered in this ginormous cookie cutter, I think you keep calling it, dividing up into these geographic areas. Each area has a class. And earlier in the conversation, you talked about using this as a set of labels that could be applied to a machine learning algorithm that was looking at satellite data. Could you walk us through that process, please, to help us sort of understand the connection again between these areas, these geographic areas, these labels, and what's possible with machine learning and Earth observation data?
Typically speaking, when you want to train an algorithm, a machine learning algorithm, or what's called a supervised machine learning algorithm, which is what we're doing, and in particular in computer vision or in deep learning, you need images and you need to know what those images represent first. And then you show those to the algorithm in what's called the training process. And the algorithm hopefully learns to recognize what's special about each label or each name or each type. And then if things work out, then it's able to recognize it later when you only show it one image, right? So that's the general process of training a supervised learning algorithm. What we're doing in our case is we're using this cookie cutter to select image patches for which we already know what they are, right? So we scan over all of Britain and we get what we call chips, which are small patches of land that are all entirely within one class, one of our signature classes. And then to that one, we save it as an example of an image and also as an example of a type. So when we then go onto the algorithm and show it, we say, for example, open sprawl, which is one of our classes. This is an example of what it looks like. And we do that with all of our classes with a lot of patches because we have a large collection, right, of this, or we can derive a large collection of these small patches. And the idea is that the algorithm learns to, well, hopefully, what the algorithm learns to is to decode all the information that the image contains, information about the building footprints that are there, the regularity of the street network, the type of materials that are used for that built environment, the amount of natural environment, all of these things. We don't tell it, you need to look at these. All we show it is the label and the colors arranged in the way that are in the image, and hopefully the algorithm is able to recognize it and decode all of that information from the image.
So if we can do this, what will this mean? Will this mean that I can take this algorithm, this process, and apply it to historical data as well? Like, I'm imagining a future where I could scroll forward and perhaps even forward and back in time and see how the urban classification as defined by these 16 classes has changed over all of Great Britain. Is that what we're heading towards?
Yeah. So before we get into the price, I'll say that it's a big if we can get these, and I think the scientific community has done a lot of progress, particularly in the last 10 years, in computer vision algorithms and other techniques. The satellite industry has also done, is undergoing an incredible revolution that is changing the way we understand Earth observation. And I think we're now just at the time where we can start thinking at least about these kinds of applications. So it's a big if, but I'm actually optimistic that if not immediately in the very near future, we will be able to do these kinds of things. Now, let's assume that that's not part of the realm of science fiction anymore and it actually works. What does it mean and why should I care? Well, one of the applications is exactly what you just said. Early in our conversation, is said that to develop this classification, we had to use a lot of data sources. And some of those data sources, they don't change very often. And they definitely don't change as rapidly as cities or the processes that we're interested in cities change. Now, Earth observation does change very rapidly, right? Images, for example, the Sentinel mission from the European Space Agency, which it's free, available, relatively granular, gives us a full picture of the Earth at about 10-meter resolution every 2 weeks, more or less. This is much more frequently than the 10 years that we get to wait for a new census. So if this idea of extracting the patterns from a granular and rich classification from vector data and then translating it into an algorithm that can pick it up entirely from images that get updated from 10 days, maybe it's a bit ambitious in a country like Great Britain because it's not known for its sunny weather, but still you can get probably a fully cloud-free mosaic every year or every 6 months. So if we can do that and we can then use these models to create an updated version of this classification as new imagery comes in, or that we can roll back on the archive of imagery that exists, then we can start thinking not only about a snapshot of urban form and function, but almost the entire film, if you want, right? Is the entire movie that tells us not only how form and function is distributed over space, but also how it changes. And if you keep pushing this vision, so to speak, you can also start thinking a world in which we start understanding how these classes evolve. And when we see one class change, we can maybe start thinking, well, maybe after this change, we can expect this other one. And maybe this other one is not something that we want. So maybe we can start thinking about policies. Or maybe this other one is one that we actually want. So how can we make it happen more often? For example, one of these changes might be densification or compactifying of cities, which is more sustainable. How can we make cities, or how can we design and invent future cities, if you wish, that are more sustainable? Well, these types of applications is what, in an ideal world, what this vision of the urban grammar is really about.
Would it make any sense at all to attach other attributes to these geographic classifications? I can't remember the specific name that you talked about, but let's say we had an urban sprawl classification and we knew that urban sprawl was particularly or wasn't particularly resilient to climate change. If we could attach that number to that classification, that help us solve problems, or would that help us look at things in a different way when we talk about scrolling back and forth through time and seeing how things change?
Yes, absolutely. So, and in fact, that's one of the main reasons why we started on this project. The urban grammar is, well, I think it's useful and it's cool in its own right. In that, if you're interested in cities as entities or as object of studies, it's a really valuable data set and notion to think about. But even if you aren't necessarily, I think it's also really interesting as a almost a. I always call it as a platform that provides urban form and function on demand. So creating these descriptions of urban form and function is non-trivial, and it takes a lot of effort and a little bit of skill. We've done this already, and now that we have it, I think there's a lot of opportunity for interacting it with other processes that we're interested in. One prime one is probably the sustainability. We know that different types of cities favor more or less sustainable models of development. So maybe we could start thinking and exploring how the signatures correlate with CO2 emissions, or how do they correlate with active travel modes. And these are not entirely new ideas. I should say that urbanists have been thinking about this for a long time. What I think is new in some ways is that we now start having the right data, the right computational models, and the right way of bringing it all together to provide data driven ways of looking at these questions, which is entirely complementary, I should say, with a more theoretical and conceptual approach for which there's a long lineage of work. And just to sort of add one or a couple more, because it might sound that sustainability or the environment is the only application. I think there's a lot of other areas that may benefit from integrating urban form and function or rich characterization of the urban fabric. There's a lot of theories, for example, going back to my economics days, there's a lot of theories about why cities are more productive and are more conducive to growth and productivity. And urban economies have been working on them for a long time. A lot of that has to do with the fact that cities are more dense environment that favor interactions between people, that you can bump into someone that does something related to what you do, and then in interacting with this person, you might come up with new ideas that you wouldn't have been able to come up in other environments. So for all of this, we have the ideas, but coming up with these rich, this data-driven descriptions is what's been, I think, more challenging. And I think the urban grammar is one step. It's definitely not the end of the story, but it's one step forward in that direction.
When you were talking there, I was wondering if you could use this to compare cities. Like if there was a city that was particularly productive or had a particular outcome, if you could use something like this to look at it and try and understand it from a form and functions perspective, and then make comparisons to another city. Why are they different? How are they different? That kind of thing.
Yeah, absolutely. And in fact, that's at the core of what we were trying to do, or we were trying to sort of quote unquote solve with the Urban Grammar project, was coming up with ways of developing rich, granular, and high resolution classifications, but that are also scalable. So go back to the British example that I was talking about, we have 16 classes, but that's based on 14 million small polygons that we used for the algorithm. Conceptually, there's nothing from stopping you in doing this in other parts of the world. you might require to dig a bit deeper or get a bit more creative with the data that you use to feed the algorithm, but it would be possible. And in fact, that is one of the core advantages of this idea, that you can build classifications that in some cases, like the one that we're doing for Britain, are entirely comparable. They are consistent and comparable. And in other cases, they might not be exactly comparable in that we're not using the same data, but they do tell you something that you can relate to other places, like the example I gave before between Barcelona and Houston.
Yeah, I'm glad you brought that up about doing a similar kind of research in other countries. The model that you have today, could I take that and apply it directly to something else, to another geographic area, assuming I could find the right kind of data? Or does the model itself need to be reprogrammed?
Yeah, so that's another great question. In theory, you could think, well, could I take a model like the one that you've developed for Great Britain and that feeds itself once trained, it only requires satellite imagery? Could I then take it to a place like France or to a place like Argentina? Because I also have satellite imagery for those areas. Could I then apply it? And in theory, you could. I mean, you could in the sense that you can feed the images from a different place and the model will spit out some estimate of what it thinks it is. However, I wouldn't necessarily recommend that because it's a model that's been trained on one reality, right? And in this particular case, on the British context, which is a very particular environment, is a very particular climate, is a very particular history, a very particular set of culture, that all of that gets reflected and encoded in its landscape. And taking that understanding of how you decode or how you interpret a particular shade of green or a particular shade of gray, that it was developed for Great Britain and then you take it to Argentina, might not necessarily work. However, and this is slightly moving into the science fiction realm, but we're not too far off from bringing it back to the science part. You can use techniques like transfer learning, which is another discipline of machine learning that has developed quite a lot in the last 10 years, and I think it's continuing to develop. What's transfer learning? Well, it is the idea that you have a model trained for one set of data, and in our case, this would be for Britain, and you then want to apply it to a different context that is not exactly the same, but it also is not completely different. Like, for example, Argentina is a very different context, but it's also a set of it's a human landscape that you're trying to analyze. So there's elements that are shared, and there are elements that are different. So what transfer learning allows you to do is take your model and retrain it or retweak it if you want, so that you can adapt the original model into the new reality. And if you do that, then you're sort of getting the best of both worlds because you're getting hopefully the parts of the original model that are transferable and those stay, but then you're also adapting the ones that are different with the new data set. And one metaphor that I have for explaining what transfer learning would do in our context is a little bit like learning a new language. If you think of our algorithm as that sort of takes images and decodes the spatial signature that's in them as a language, we have the British language, so to speak, or we have English. If you're going to go and learn Spanish because you're going to Argentina, you probably cannot use all the rules and the syntax that English uses. But if you're starting from a point where you already know English, you already know something about Spanish because they share a lot of commonalities. They have some common history, etc. So you don't start from scratch. And what transfer learning does in some ways is what we do implicitly when we learn a new language that shares something but is not exactly the same as the one that we speak.
Wow, it's a lot to take in. I've often heard people talk about this as, or describe it as programming a model as you program it with data. You give it new answers, kind of thing. So yeah, you have a model that works in a specific geographic area. We give it a bunch of new answers to the new area that we're interested in, and then you don't have to start from scratch like you're saying. You can move on.
That's right. That's it. That's exactly what it does. It part of why transfer learning works is because there's a lot of elements in training for the new data set that are shared with the old one. So for example, there are streets, there are buildings, there is greenery. Now, what those mean and what how those are organized might be different. But if you have an algorithm that the first thing it needs to do is to recognize basic patterns, basic building blocks like building footprints or what could be related to building footprints, then you don't need to start from scratch for those. You can transfer learning allows us to take those elements that are already sort of figured out, if you want, in between quotes, and then retrain and tweak the ones that are specific to the new data set.
Hey, Danny, I want to thank you very much for walking me through this, for helping me understand this amazing piece of work that you're doing and the potential ramifications of it, like what we will be able to use it for in the future when it works. So I'm an optimist, so I'm going to say when it works. But it's kind of a visual thing. So you've created all these polygons, and I know that you've got a map somewhere. If there's people out there that are listening to this and think this sounds amazing, where can they go to see it? Or where can they go to read more about this project and understand the steps that you've been through?
Yeah. So the project has a website, urbangramarai.xyz, and it also has a page on the Alan Turing Institute's website, turing.ac.uk. But really, because we're still advancing quite a bit, and we're giving talks, and we're sort of generating new content, so to speak. If you want to learn more about the project, I would probably say the best way to stay in touch with the project is either follow me on Twitter at the Arribas or Martin Fleischmann at Martin Fleisch. We'll keep you posted. And there should be academic articles coming out soon. We have a few talks that we've recorded, and there's a lot of background information on the website. And if anything, I would say that use that just as a springboard. But if you're interested, please drop me or Martin a line and send me an email or send me a direct message on Twitter, and let's start a conversation. We're really, really thrilled to see how people receive these and how they might want to use it. So please get in touch.
Thanks very much for being so open about that. I hope that people take the time to reach out to you if they're interested or just want to continue this conversation, want to learn more. Thanks very much for your time. I've really enjoyed talking with you.
Yeah, thank you very much, Daniel. And thanks very much for the community service you do with the podcast. It's a fantastic way of getting to know more about the geospatial. So thanks very much for letting me come here.
So once again, a big thank you to our sponsor, Regrid. If you are looking for parcel data for the US, regrid.com would be a great place to start. I'll put a link to them in the show notes to make it a little bit easier for you to find. So I've been producing this podcast for about 3 years now, and it's by far one of the most meaningful and enjoyable things that I've done in my professional life. But meaningful and enjoyable is not the same as sustainable. And in order to make this podcast sustainable, I need your help. So in terms of helping you, you have two options. There's a free option and a paid option. The free option is just help me promote this podcast. Help me reach more people. Help me build a bigger audience. Share this podcast with your network. Link to it from a website. Nothing spammy, but just help promote this podcast. So this is the free option. The paid option, option number 2. I'm going to try and crowdfund this podcast. So last week I created a Patreon account. There'll be a link to it in the show notes. If you are in a position to contribute, please consider it. I would really appreciate it. So it is unlikely that this podcast is going to make me rich. I do it because it's meaningful for me. I do it because I think it's making things better, and I enjoy doing it. But I've also become painfully aware that it needs to be more sustainable. It's not easy to ask for help, but I'm going to do it anyway because this means something to me. So if you would consider helping me with one of those two options, I would really appreciate it. So right at the start of this episode, I mentioned that I had a few resources for you, and the first one is pretty obvious. The first one is the website that Danny talked about. This is urbangramarai.xyz. The next two are actually previous podcast episodes. So if AI is new to you, check out an episode called An Introduction to Artificial Intelligence. So the name says it all with this one. It's a gentle introduction to artificial intelligence, what it is and what it is not. It's worth checking out. If you want a more sort of detailed look at artificial intelligence in terms of finding objects and segmenting images, there will also be a link to an episode called Collecting and Processing Aerial Imagery at Scale. Again, there'll be links to both those episodes in the show notes. Okay, that's it for me. That's it for another episode of the Mapscaping podcast. As always, you're more than welcome to reach out to me on social media. You can find me at Mapscaping on Twitter. Again, there'll be some information in the show notes of this episode. Thanks very much for listening. I'll be back again next week. I hope to see you then.